I want you to first think about water flowing through some pipes. There is a pump which pushes this water, and the pump is equivalent to our battery in the circuit. The pipe will split into two branches, and the pipes are equivalent to our wires. One branch has a pipe with a reducer in it, and that reduction makes it a little harder for water to flow through it. So the reducer is equivalent to resistance in our electrical circuit. The other branch has a water wheel built into it. The water wheel can rotate, and the water flowing through it will cause it to rotate. The wheel is very heavy though, so it takes some time to get it up to speed, and the water has to keep pushing against this to get it to move. This water wheel is going to be equivalent to our inductor. When we first start the pump, the water is going to flow, and it wants to get back to the pump as this is a closed loop. This is just like when electrons leave the battery, they flow and try and get back to the other side of the battery. By the way, in these animations I use electron flow, which is from negative to positive, but you might be used to seeing conventional flow, which is from positive to negative. Just be aware of the two and which one we're using. So as the water flows, it reaches the branches and has to now decide which path to take. The water pushes against the wheel, but the wheel is going to take some time to get moving, and so is adding a lot of resistance to the pipe, making it too difficult for the water to flow through this path. Therefore, the water will instead take the path of the reducer because it can flow straight through this and get back to the pump much easier. As the water keeps pushing, the wheel will begin to turn faster and faster until it reaches its maximum speed. Now the wheel doesn't provide almost any resistance, so the water can flow through this path much easier than the path with the reducer in it. The water will pretty much stop flowing through the reducer, and it will all now flow through the water wheel. When we turn off the pump, no more water will enter the system, but the water wheel is going so fast it can't just stop, it has inertia. As it keeps rotating, it will now push the water and act like a pump. The water will flow around the loop back on itself until the resistance in the pipes and the reducer slows the water down enough that the wheel stops spinning. We can therefore turn the pump on and off, and the water wheel will keep the water moving for a short duration during these interruptions. We get a very similar scenario when we connect an inductor in parallel with a resistive load such as a lamp. This is the same circuit as we just saw, but I've just wired it more neatly. When we power the circuit, the electrons are going to first flow through the lamp and power it. Very little current will flow through the inductor because of its resistance at first is too large. The resistance will reduce and allow more current to flow. Eventually, the inductor provides nearly no resistance, and so the electrons will prefer to take this path back to the power source rather than through the lamp, so the lamp will turn off.